Alright, this is Physics Lab 1, Constant Velocity by John Ensley. So we're going to be looking at constant motion, constant velocity, and then we're going to use tracker and glow script to create two models that one observe, one predicts, and we're going to compare those. So our principles are going to be position update, mainly because our position is changing with the constant velocity, which goes right here because it's not changing. We're not going to need this because the velocity is the same the whole time, and we're not going to need kinematics because F-net's going to be 0. Because there's no F-net's going to be 0 because constant velocity, so this is going to cancel out. It's going to leave us with our position update. So basically, this was our overall, or my overall results. So the blue data set is the computational model. It's more smooth because it's a perfect calculations. The tracker is the yellow dotted line. It varies a little bit because possible error, but overall they were for the most part similar and had a general trend. So once again, we're going to be mainly using this because our position is changing, but we're not going to need this because velocity stays the same. But it's important to note Newton's first law that the velocity should stay constant unless acted on by a different force. And our position update comes from Newton's second law. And once again, we're not going to need kinematics because this is going to be 0. We're not going to need force because F-net's going to stay the same, which is 0. And we're not going to need gravity here because we're just looking at movement in the x direction, plus x direction. And our system is going to be this frictionless moving car on this frictionless track, but the surroundings is going to be things like the table, everything else, like the track's going to be the surroundings. So we're just looking at how the system's moving. And then for our initial conditions, we're going to have 8.241 times 10 to the negative 2. That should say meters, I believe. But basically it's 0. We're starting basically at 0, and we're going to have initial velocity of 0.919 meters per second. Use that, or we found that by using tracker. And once again, there's going to be no friction because it's a frictionless track. No gravity, and the velocity is going to stay constant. F-net's going to be 0. And here's the meter for the calibration stick. Yeah, once again, this is the experiment, plus x direction. And here's the video of it moving. So as you can see, it makes this graph for us, distance over time in meters per second. And here's the data from it. There it is again. And then here's the computational model. So up here is our starting values. Here's the velocity and the position. And here's where we start the time, and here's each time step in our data. The ending time is going to be, we ended at 0.96, so it's less than 2. And then here's the main part. So this is where we put our position update. So here is the final position equals initial position plus the constant velocity we have times the delta t, so the time stamps we had up here. And once again, we don't need velocity update because it stays the same. Here's the computational model. So as you can see, it uses perfect calculations, so it's pretty smooth. And here's the velocity of that, and it's constant, so it stays the same, which makes sense. And here is the tracker data, so it moves around a little bit because it's not perfect. And here's the perfect calculations done by the computational model. And as you can see, overall they have that general trend, but the tracker deviates a little bit, possibly to other forces and possible error. And again, they show a general linear trend. Around 0.2 seconds, they really deviate a little bit. The tracker one goes a bit up, or the distance goes a little bit farther. And once again, the computational model is going to be smooth, and they cover the same interval, and they start and end overall in the same area. So here's some error. We didn't account for air resistance. Also, camera warp could be a problem with like how you're looking at it in our video. And then using the tracker tool can come with some error. And for the discussion questions, so if we flipped the x and y axes, we made plus x negative x, then it's going to make all the points basically the same, except they're going to be negative, as well as the slope. The slope's going to be negative, because you're going in the opposite direction. But the magnitude, the velocity goes negative too, but the magnitude of that is going to stay the same throughout the entire experiment because it's constant. And overall, there's not really a great way, even though F net is 0, there's plenty of forces happening, but they're canceling each other out. So it's very difficult to pinpoint each and every force that are canceling each other out. But we just know that since the velocity is constant, there's no other forces acting.